Hello, welcome to lesson 1.1. This is Mr. Henry, and this lesson we're talking about properties of exponential expressions. Now, this is an extremely long lesson, probably split over 3 or 4 days in class. I'm probably going to break it down into two smaller videos because there's a lot to cover. There's quite a few properties of exponential expressions that we need to get to, and being able to use them all in concert with each other takes quite a bit of practice. So, yeah, be prepared. So the essential question says, how do I use properties of exponents to simplify expressions? Seems fairly straightforward. Did you know that after the zombie apocalypse, let's say there are 10 people alive, and a pair of people, two people, is able to have about 4 children. And then each of these 4 children, as they grow up, they can have 4 children, and so on and so on and so on. It says it would not actually take very long for that group of 10 people to grow to a community of about 1,000. It'd only take about 4 generations, it looks like. And that's kind of the way that exponents work. Exponents grow very, very fast. And so if there was, if each group of couple was able to have, say, 6 kids, then it might only take 3 generations to reach 1,000 people. They just grow that much faster. And that's kind of what happens with the human population. For the longest time, we had very little people, just like long time ago. And then as we start getting more people, the population starts growing a little bit faster and a little bit faster. And as you get more people, it gets faster and faster. And then you start getting this kind of curve shape where this now, it starts going up really, really fast. I mean, we're kind of like somewhere in this stage, probably of the human population, where we're getting to the point where we're gonna start exploding our population. We're having with as many kids as people are having, with as many the population we have, people having more children, it's just gonna grow exponentially fast. Is the word that we're using, which is apt because we're talking about exponents. Okay, so we have a couple vocab words here we have to talk about. We've got base, exponent, and power. So a base, when you're talking about powers and exponents and stuff, a base is the larger number on the bottom of a power. So for example, if I'm going to use the example 5 to 3. So in this case, the base is the 5 from that. That 5 is the base. It's the big number on the bottom. It's the number that is going to be multiplied by itself multiple times. The exponent is the little number on the top. That, in this example, is the 3. And that is how many times the base is multiplied by itself. So, since that says 5 to the 3rd power, we would take 5 multiplied by itself 3 times. If that was an 8, you'd take it times by itself 8 times. So that exponent says how many times the base is multiplied by itself. And then our power is kind of the base and exponent put together. So this whole thing, this 5 to the 3rd power, is called a power. Or here, 8 to the 3rd power is a power. You can read this a couple different ways. You might hear people say 8 to the 3rd power, 8 to the power of 3. This one could actually be read as 8 cubed. Certain exponents have their own special names, like you've seen in the previous unit 0. If I had this, we can say that's 5 squared, 5 cubed. Now it goes 5 to the 4th power, 5 to the 5th power, 5 to the 6th power, and so on like that. So, our first properties. So the directions ask us to simplify each expression. Answers should be expressed with only positive exponents. You're going to see that a lot. We do not want negative exponents in our final answer. That's one of the things we get rid of. It's kind of like when you're dealing with fractions. The last episode always simplify your fraction. It's kind of the same deal. You don't leave exponents or you don't leave your expressions with negative exponents at the end. That's one of those things you just got to get rid of. Okay? But we don't have to worry about them for a little while because, well, the negative exponents are the second half of the lesson. So to do this problem, we want to take 7 to the 4th power times by 7 to the 5th power. we are multiplying two powers together. We're doing the product of a power, multiplying two powers together. And when you're multiplying two powers together, you add the exponents. So I'm going to give you the shortcut answer. This is going to be 7 to the 9th power. You take, sometimes you'll see it written like this, 7 to the 4 plus 5, 7 to the 9th power. Now here's why this works, okay? So there's the shortcut answer. That's the answer we're going to get. And here's why this works. This 7 to the 4th power is 7 times 7 times 7 times 7. This 7 to the 5th power is 7 times 7 times 7 times 7 times 7. And they're being multiplied together. So you see there's 4 7s times by 5 7s. And I have them in different colors. You can keep them separate. But if I would change these all to the same color, now it's just a bunch of 7s being multiplied together. And how many 7s are there? Well, there are 9 of them. 4 from here, 5 from here. All together makes 9 7s. So if you have two powers that are being multiplied together, add the exponents. Let's try it again. Here, letter B. We have b to the 3rd power times by b to the something. And we want to multiply these together. So we got to figure out what exponent is here. And I'm going to be very careful about not putting a 0 because it's not a 0. Like if I want to put a circle to like what power is up there, understand it's not a 0. Because if this was b to the 0 power, we're going to learn later on what happens there. But if there's b to the 0 power, we a lot of times just wouldn't put it at all. So when you don't see an exponent, that means there is a little ghost 1, a little invisible 1 there. So this is b to the 3rd power times by b to the 1st cubed times by b to the 1st. And if we add your exponents together, how many b's are being multiplied together here? There's 3 from here, 1 from here, makes a total of 4 b's are being multiplied together. 1, 2, 3 from here, all being multiplied, 4 b's. Multiply powers, add the exponents. Okay? I would like you to try these next two. Now they may look tricky or difficult, but it's the exact same thing. Use the same patterns we did above, down below, and I bet you'll get them right. So go ahead, pause the video, try them on your own. When you're ready to continue, hit play, and we will go through them together. Okay, so letter C. So this -2 inside the parentheses is just the base. 2 and the 5 and the 2 up top are the exponents. So this is going to be -2 to the 5 plus 2 power. How many -2's are being multiplied together here? Well, I've got 5 of them here, 2 of them here. All together, there is a total of 7 -2's being multiplied together. And notice we don't have to multiply this out. I didn't multiply it out here. I left it as 7 to the 9th power. Here, b to the 4th power. Okay, letter D. How many h's are being multiplied together? I've got 12 h's here, all being multiplied together. H times h times h times h times h, 12 times 11 more of them. So I'm going to take h to the 12 plus 11th power to add my exponents together and get h to the 23rd power. Now, very quickly, we can probably check this, at least like this one or this one on our calculator here. This number is probably too big to fit the entire thing on the calculator, but let's see. Here's how you would type in an exponent on a calculator. 7. Now we're going to use this caret key. Now, I'm not going to hit second. If I hit second, that does that little special root. I just want caret. That caret key is how the calculator understands exponents. So this says 7 to the 9th power. Calculator gives me, okay, it does actually, it can fit all the digits there. But it's a big number. I mean, that is 40,353,607. I typed in this. Now, if we type in this, 7 to the 4th times 7 to the 5th. I'm honestly a little cautious if the calculator is going to do this right, or if it's going to think I'm doing 7 to the 4 times 7 to the 5th, which is a valid math problem. It's ugly. That's a valid math problem. But I think the calculator is going to interpret it properly. Okay, it did. And you see we have the right answer, the same answer. That's proof that this and this are the same. And if I check this out, I think I can do this another way. 7 to the, in parentheses, I'm going to put in 4 plus 5. 4 plus 5. Parentheses. So it's going to do this, it's going to add these together first to get to the 9th power. Same answer again. Okay. So I was just showing this a couple different ways so you can verify. You can try it on your own calculator to see that when you add the exponents together, two powers being multiplied together, you add the exponents and you get the same equivalence answer. Okay. Now, what about if we are dividing? Here, 5 to the 4th power divided by 5 to the 2nd power. Okay, so what we're going to do is when you are dividing, just like, okay, the opposite. Here, when we were multiplying the powers together, we added the exponents. So now we're doing the opposite. Instead of multiplying, we're dividing the powers. So instead of adding the exponents, we're going to subtract them. So this could be interpreted as 5 to the 4th minus 2. I'm subtracting my exponents. I'm taking the top one minus the bottom one, 5 to the 4 minus 2 power. And that should give me 5 squared. Now, I'll be honest with you, that is not how I personally like to do these problems. Okay, that's kind of the textbooky way, the way that the textbook likes to show, and some people may really like that way. Maybe you don't like the way I'm going to show you, but I want to show you how I do this. When I do this, I don't think of it as subtraction. I sort of do. I think it more of canceling. Okay, up top here, I have 4 5s. 1, 2, 3, 4, all being multiplied together. On the bottom, I have 2 5s. Now, I like to think of this as canceling. If I start canceling, 1 5 up top and 1 5 down below. One more up top, one more down below. And I can't cancel anymore because I don't have any more 5s on the denominator of my fraction. So what is left after I've done the canceled 2 of these and I've canceled 2 of those? I'm left with 2 5s on the top. 2 5s on the top. This technically be as a fraction would be over 1. That is how I like to do my dividing of powers. I like to think of it as canceling. Some people like subtracting. When it's written like letter F here, this next problem, subtraction might be the easier way to do this. I mean, this is, I need to subtract these powers. So you could say, okay, that's just y in the 7 minus 4, which is y to the 3rd power. You could think of it as canceling. If I would write this another way, that's the other way you'd write this, as a fraction. If I cancel 4 of these, and I cancel 4 of those, these will be all gone. And here, I would be left with, if I cancel 4 of them, I'd have 3 left over. I'd be left with y to the 3rd power. It's the same thing, slightly different method. I personally like canceling. Some people like subtracting. You just got to find what works best for you. So here we have letters G and H. So I'd like you to try and do right now. So pause the video, try them on your own. When you are ready to continue, hit play, and we will go through them together. Okay. So final answers, you should have m to the 4th power and negative 8 inside parentheses to the 3rd power. If you did this as m to the 6 minus 2, you subtracted your exponents to get that. Awesome. If you did m to the 6th over m squared and you canceled 2 of these and you canceled 2 of these, and so you're 4 left to get that answer, that's awesome too. Same dealio here. Hopefully you understood that this meant there is one of these on the bottom. There's no exponent, there's one. So then you would take and you would do -8 to the 4 minus 1 power, and that is a 4, not a 9. -8 to the 4 minus 1 power, which is that. Or if you started doing the canceling method and -8 to the 4th over -8 to the 1st, and you canceled these out, which means there's no more. There's nothing left down here. Canceled one of these out, get the same answer. Okay. The second property we're looking at today is called the power of a power. So we're going to be taking a power. My cursor, there it is. We're taking a power and we're raising it to another power. So this 4 squared is being raised to the 6th power. The whole thing is being raised to the 6th power. So if you think about this, another way we could write this that maybe help it make sense to what we're doing here, this 4 squared is going to be multiplied by itself 6 times. Save me some writing. 1, 2, 3, 4, 5, 6. So 4 squared is being multiplied by itself 6 times. 4 squared to the 6th power. And each of these 4 squareds is 4 times 4. So 4 times 4 times 4 times 4. The whole way across. There we go. Close enough. And so what we end up with, well, how many 4s now are being multiplied together? In my final expanded version of this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 4s being multiplied together. 4 to the 12th power. Now, do you see some connection between what I have here and what I have here? What looks like is happening? Take a guess. If you're thinking it looks like you took the 2 times by the 6, you're absolutely right. That is the property. When you have a power of a power, you multiply the exponents together. So we took the 2 times by the 6 to get to 12. Power of power, multiply the exponent. Here, same deal. Now, this 2/7 is my base. The whole thing, 2/7 is the base. I'm going to just go ahead and leave it like that for now. So I'm going to take 2/7 as my base, and he's going to be raised to the 6 times 4 power, to the 24th power. Because again, this is 2/7 to the 6th power 4 times. This times by itself 4 times. 1, 2, 3, 4. Okay? And then each of these, I would take 2/7 and I'd break it down to be 6 of them. 6 here, 6 here, 6 here. Well, 6 4 times is 24. That is my simplified final answer. Okay? I would like you to try these two. So go ahead and pause the video. You can use our previous 2 examples to help guide you through the process. When you're ready to continue, or if you get stuck and you need some help, hit play and we'll go through them together. Okay, so we have -x to the 4th power cubed. So let's see here. -x. Ooh, that's not an x, that's a 4. -x the 4th power cubed. That would give us negative x to the 12th power. Right? 4 times 3, because that'd be negative x to the 4th. I did it again. Negative x to the 4th times negative x to the times negative x to the 4th. And each of these can be broken down and multiplied back together to give us, there would be 12 x's being multiplied by it together. Letter D. Power over power. Now, another way you might think of this, and maybe you thought of this as we were going through, this is actually going to be kind of like the distributive property. If you remember the distributive property from 7th grade, we haven't talked about it yet this year. The distributive property is you take the number on the outside of the parentheses and you multiply by all the numbers on the inside of the parentheses. Now, in terms of exponents, the way that works is you take the exponent on the outside and you multiply it by all the exponents on the inside. So 3 times 4 is 12. 5 times 6 is 30. 5 times 6 is 24. 6 times 2 is 12. And this idea of the distributive property actually works even if there is more stuff inside. But let's finish letter D first, and then I'll go off on that tangent. Actually, I think that's in the next lesson. Oh, we'll get there. We'll see. So 1.8 to the 30th power. You take and you multiply your exponents together. That is the 1.8 of the 6 times 5 power, which is to the 30th power. Okay. Simplify each expression. Answer should be expressed with only positive exponents. So basically, all we've done now is we're going to take those two and we're going to expand a little. Take those last example and make them a little bit harder, a little more challenging to them. So we have here, inside my parentheses, I have 2a. This expression is being raised to the 5th power, and then that is being raised to the 3rd power. So I'm going to take my 2a, and he's going to be to the 15th power. Power of a power you multiply. And I do need to leave him inside parentheses because 2a to the 15th and 2a to the 15th with parentheses like this are actually very different. In the top one, the 2 and the a are to the 15th power. Down here, the 2 would actually be to the 1st power, and the a is to the 15th power. These are different, okay? The one we want is that one. So if you see parentheses up top, usually you want to leave them in there. Letter F. Now, I said it's kind of this outside exponent is kind of like the distributive property. This will be an example of that. Check this out. I'm going to take the 8. Oops, I need to make him not ghost mode. I'm going to take the 8 and multiply by that 2. The outside exponent gets multiplied by the inside exponent. So that becomes h to the 16th power. But I also need to take this 8 and multiply by the exponent on that 5. This 5 has an exponent too. Do you see it? It's not him. He's attached to the 2. I'm sorry, this 2 is attached to the h. The exponent on the 5 here is to the 1st power. So what this becomes is, this becomes 5 to the 8th power. 8 times 1, it's 8. And h to the 16th power, because 8 times 2 is 16. We're using this, it's kind of like the distributive property. You take the outside exponent times by all of the inside exponents. The reason why I did not do that here is because these parentheses are kind of like a force field saying this stuff all stays together, so when you distribute here, you can't get in here to distribute this 3 to the 2 and the a. Okay? The exponent there is the 5. So that's why I could not do it in that previous example. And don't worry, I understand this could be confusing and difficult. We're going to see lots of examples and go through them, okay? So if it's confusing, Try them out. The worst thing that happens is you get a wrong answer, and we fix it when we go through it together. But at least you made the effort and you thought through the problem. The best thing that happens is you get it right and you're perfect. Okay? So go ahead and try letters G and H. Use our previous examples to look back on if you need to. Try to simplify letters G and H. Pause the video. When you're ready to continue, hit play, and we'll go through it together. All right, so letter G. Outside exponent times by the inside exponent. The 4 can't penetrate inside these parentheses, so that's really the only thing you can do. So this becomes 1/3 parentheses to the 4 times 9 power. That's the 36th power. And we're going to leave it like that for now. Letter H, if you took the previous example, letter F here to heart, you took the outside exponent times by the inside exponent, giving you j to the 21st power. But also this 3 needs to be multiplied by this exponent, not the 3. I'm not taking 3 times 3 and getting 9. That's wrong. I need the exponent on the 3. And this 3, if you don't see an exponent, it means there is one of them right there. And so 3 times by the exponent here gives me 3 to the 3rd power. So my final answer is 3 to the 3rd power, j to the 21st power. Outside exponent, multiply by all of the inside exponents. Exponents times exponents. I am not taking an exponent times by this base. Only little numbers times little numbers. Little times little. Little times little. Little times little. Little times little. So now what we're going to do is we're going to combine our previous examples together. So the problems are going to get a little bit more complex. They're going to have more stuff to them we have to think about and do. But it shouldn't be that bad. Okay. So here, I see I have some parentheses. I have an exponent on the outside, and I have 1.5 fifth and 1.5 to the first. I'm going to go ahead and throw that 1 in there because I'm pretty sure I'm going to need them. So this problem could actually be done 2 ways. One way you could do this is you could say, hey, well, you know what? I can actually combine this together. These powers have the same base. They're both 1.5. And so I remember that if I have 2 powers with the same base that are being multiplied together, I add the exponents. 1.5 to the 6th power. And then all of that is still to the power of 4. And so now you go, oh, okay, so I'm going to multiply my exponents together and get 1.5 to the 24th power. I'll make that 24 a little bit smaller because he was looking a little big. So that's one way you could do this. The other way you could do this is you can say, you know what? Back in. I'm going to take my outside exponent and I'm going to distribute him to all the inside exponents. So this becomes 1.5 to the 20th. This becomes 1.5 to the 4th. And now my parentheses are gone. That's kind of the whole point of distributing, right? To get rid of the parentheses. My parentheses are gone. And since I still have 2 powers with the same base that are being multiplied together, I can add the exponents. And 20 plus 4 is 24. So I got the same answer no matter which method I chose. You might like one way better than another. That's why I showed both methods. What you have to be able to do is you have to be able to see at least one of the methods and be able to work through the problem. You may not be able to see both of them, and that's fine. You don't have the experience that I do. Letter B. So here's what I'm seeing. The very first thing I see is I see parentheses. I want to get rid of them. So I'm going to start by distributing my exponents. So this 3 exponent times by this exponent becomes g to the 6th power. This 3 times by this exponent, what's the exponent here? this 2 has a power, has an exponent of 1. Don't see it? It's the first power. So that becomes 2 to the third power. 3 times 1 is 3. And I'm writing down the rest of the problem. Here's my multiply by 5 that I have here. Now I look to see, is there anything else I can group together? Anything else I can add or subtract or multiply? Things with the same base. Yep. I've got 2 g's. I've got g to the 6th. I've got g to the 5th. Those 2 guys are the same base. Since they're being multiplied together, I can add their exponents. So this becomes g to the 11th power. And I'm just going to leave him as 2 to the 3rd. He doesn't have anybody to combine with. There's no other guys with a base of 2 for him to combine with. So he is, well, done. And this is actually as simplified as we can get. One more that we're going to do together, then you're going to try one on your own. Letter C. So, again, I see this outside exponent, and I'm going to distribute him to the inside exponents to get rid of them. So I'm going to distribute the 7 to the exponent of this, distribute the 7 to the exponent of that. I'm multiplying exponents. So here, that gives me 1/5, in parentheses, to the 28th power. Here, that gives me 1/5, and I'll go ahead and throw parentheses, even though he doesn't start with them. 1/5 to the, well, right now, this guy, this 1/5, has a power of 1. I know because I don't see it. So I take 7 times by 1, and I get 7. And this looks like one of our previous examples from a while back, but we're just going to add the exponents together. I've got 2 powers with the same base. That's important. They have to have the same base. Then I could just add the exponents together. So this becomes 1/5 in parentheses to the 35th power. 28 plus 7, 35, yeah. And there we have it. I used my outside exponent and I distributed them to the inside exponents. I then combined my like terms, my 2 powers that had the same base. I added their exponents together, and I was done. Now you try. This is letter D on your paper, so go ahead and copy him down. Pause the video, try the problem out, use our previous examples if you need to. When you're ready to continue, hit play, and we'll go through it together. All right, so first thing I see is these parentheses. I don't like them. I want to get rid of them. So I'm going to distribute. Now, I am not going to do this because this r is not inside those parentheses. This 2 is not being multiplied by him. This 2 is not on that r. Okay? So that is no good. What we're going to do is we're going to multiply this guy, giving me r to the 16th power. This guy just stays r. Now, I'm going to go ahead and throw an exponent of 1 in there. Again, if you don't see an exponent, it means it's to the first power. Now I have 2 powers, the same base, the r's, being multiplied together. So I'm going to add the exponents. There's a total of 17 r's being multiplied together here. So I'm going to write that, r to the 17th power. So just pausing a second so you can take a look back if you need to. Pause the video if you need to. Yeah, we're moving on. Same deal. Just of the same. So we want to simplify as much as we can. So here I'm going to get rid of my parentheses first. I really don't like them. So I'm going to distribute the exponents. 4 times the 4. And this 4 times by the exponent on the 5. So that's going to give me 5 to the 4th power, m to the 16th power over m cubed. That m cubed, nothing really happened with him, so he just kind of stays by himself. Okay, so my parentheses are gone. The next thing I'm looking for, is there anything that I can combine together? Or if I have more than one of the same variable, or the same base, I guarantee I can do more stuff with it. So like this m and this m, these two m's, something can happen with them, so that in the end I only have one m. And the thing I can do is I can cancel some of these out. I have 3 m's I can cancel here, 3 m's I can cancel here. And what's left over? Well, down the bottom I have nothing. Those are gone. Up top, I would still have 13 m's left over. 16, take away 3, is 13. So my final answer here is 5 to the 4th power, m to the 13th power. I distributed my exponents. I canceled my quotient, my division of 2 powers. I subtracted them. Okay, looking at letter F, first thing I see is parentheses. So I'm going to deal with that a little bit. So I can distribute my exponents. This becomes 6 to the 12th power and 6 to the 6th power. Now, I kind of still need to keep my parentheses simply because it's taking this stuff here divided by this stuff here. I mean, we could write this another way. We could write this as a fraction. 6 to the 4th times by 6 squared, all to the 3rd power, divided by 6 squared to the 3rd power, like that. So when I did this distributing, basically I simplified the top of the fraction. And now when I distribute here, I'm simplifying the bottom of the fraction. Okay. Now, is there anything I can cancel out, or simplify, or add? Well, I see that I have a base of 6. All 3 of these have a base of 6. Those eventually are all going to simplify and combine into one thing. I'm only going to have one base 6 in my final answer. So I'm going to start by simplifying the top a little bit. This, I'm going to add the exponents, giving me 6 to the 18th power. 12 plus 6 is 18. There are 18 6's all being multiplied together on the top. Now, we saw, even in this previous example, if you have the same base on the top and the bottom, the way you cancel them out is by subtracting, or I like to think of it as canceling. So if I cancel 6 of these and 6 of these, I have no more on the bottom, but I still have 12 of them up top. So I would get a final answer of 6 to the 12th power, and just so you understand, this would be on the top of the fraction. You don't need to write it as a fraction. I'm just letting you know that that 6 to the 12th is in the numerator. There will be times, shortly, later on, where it may be in the denominator of the fraction. And it's important to make sure you understand which is which. Okay, here are 2 to try for yourself. Letters G and H. Letter G looks a lot like letter F, so maybe you use that as your example to look off of. And letter H looks similar to letter E. So go ahead and pause the video, try these 2 on your own. When you are ready to continue, hit play and we'll go through them together. Okay. So I'm going to distribute my exponents. This gives me p to the 6th power. This gives me p to the 10th power. And since this is a multiply, I'm just going to continue to multiply to the 7th power. So this stuff is being multiplied by this. When I distributed, it's still, even if I put parentheses here, if it makes you feel good, it's still this stuff is being multiplied by this. And if I would simplify here, I would add my exponents together. I've got 16 p's being multiplied together right here. P to the 16th, and that is being multiplied by a p to the 7th. So all together right here, I have 23 p's being multiplied together. Letter H. I see every one of these bases is a base of 7. So in the end, I'm going to simplify down to just something like 7 to the... I don't know the answer. I didn't do the problem yet. But imagine 7 to the 8th power, 7 to the 32nd power, something like that. But it's just going to be 7 with a power. All right, so what are we going to do? Well, first thing I'm going to do is get rid of my parentheses. I'm going to distribute the exponents. So this guy, it's helpful if I can see the exponent. So I'm going to throw him in there. This becomes 7 to the 8th power times by 7 squared over 7 to the 8th power times by, the whole thing times by 7 to the 9th. Up top, 7 to the 8th power times by 7 squared simplifies to give me 7 to the 10th power. That's supposed to be a multiply. Multiply by 7 to the 9th. Okay, if I can simplify this fraction, then I'll take whatever I get here and multiply by 7 to the 9th power and I'll be done. So my fraction piece here, I can cancel. I can subtract. I have 10. I'm going to take away 8. I'm going to take away 8 of them down here, take away 8 of them up here. Nothing left on the bottom, but there still would be 2 up top. 10 minus 8 is 2. So this becomes 7 squared, right, times by 7 to the 9th power. And my final last step is, if I combine these together, I have a total of 11 sevens being multiplied together. 2 here, 9 here, total is 11. Pause if you need to, look back and examine and question why everything is the way it is. If you don't remember, scroll back in the video a little bit, and I probably said it. Example 3. So just more of the same. I have, looks like one more for me to show here. Now this looks really hard. Lots of junk going on here, but it's not that bad. And then you're going to have a couple for you to try on your own. So the first thing, it's the same the first step I've done in the previous couple examples. I'm going to distribute the exponents on the top to get rid of those parentheses. So m, and him. So this becomes h to the 15th power, p to the 10th power, m to the 10th power, all over h to the 10th m cubed. So that nothing happened on the bottom. They stayed exactly the way they were before. All right. I look at the top. Is there anything else I can combine together? The answer is no, because these all have different bases, h, p, m. And there's nothing I can do on the bottom because they have different bases. So now I start looking, is there anything I can cancel top and bottom? Looking for the same bases. So like here, I've got 2 h's. These h's, I can do a little bit of canceling. I can cancel 10 of them here and 10 of them here. So if I cancel 10 here and 10 here, I'm left with 5 up top and none down below. For my m's, I can cancel 3 of them here, 3 of them here, leaving me 7 left over up top and nothing down below. So my final answer is h to the 5th, e to the 10th, m to the 7th. And nothing on the denominator. Here are 3 to try on your own. Don't get disheartened that they look really big and ugly. Start working through them one step at a time. Get rid of those parentheses. I see all of them have parentheses to get rid of as their very first step. Then start adding like terms that you can. Things that have the same base. See if you can add the exponents together. And look for things you can cancel out. Okay? Go as far as you can. Please pause the video. Try these 3 problems out as far as you can on your own. When you're ready to continue or when you get stuck, hit play. We'll go through them together. All right, letter J. So here's what this says. This says I have negative 2 cubed times by negative 2 to the 8th power. Then all of this, now they're using square brackets here, which is the right thing to do. All of this is to the 9th power. And then this stuff is being divided by negative 2 parentheses to the 4th power in square brackets squared. That may not look any easier to you. So basically what we're going to do is we're going to take and we're going to get rid of these brackets by distributing our exponents. So I'm going to distribute up top, and I'm going to distribute down below. So what that's going to give us, up top, I'm going to have negative 2 to the 27th power, 9 times 3 is 27, times by negative 2 to the 72nd power, 9 times 8 is 72, all over negative 2 to the 8th power, times 2 is 8. Okay, it's a little bit prettier. I'm going to simplify the top, and then worry about my top and bottoms. So if I simplify the top here, I've got negative 2 to the 72 times by negative, or 27 times by negative 2 to the 72. That's going to give me, if I add my powers together, because I've got negative 2 times by negative 2, they're adding the exponents together. Negative 2 to the 99th power over negative 2 to the 8th. And now if I cancel out 8 of these, there's none left. If I cancel out 8 of these, there's 91 left. So my final answer is negative 2 to the 91st power. Ugly. But it's the same steps we did before. It just looked uglier because this negative 2 was in parentheses. And so we had to add square brackets to make it look a little bit prettier. Letter K. Parentheses. Times by this exponent, times by this exponent, times by this exponent. All of these things are being separated by multiply. So they each have their own exponents. This has an exponent, this has an exponent, this has an exponent. And you might have forgot that this 2 needed an exponent. So what we should get after we distribute the exponents is g to the 24th power, 2 to the 3rd power, g to the 3rd power. If you got that far, hey, congratulations. Good job. And this other stuff just kind of stays the way it is. Now, maybe I'll throw a little multiply sign in here just so you understand that it's g times by, 6 times by g to the 5th. So you can understand that they're kind of separate pieces. These are all, 5 separate pieces that can be rearranged and grouped together as we see fit. Speaking of grouping together, do you see anything with the same base that we can add the exponents together? I see g's, g's, g's. I've got 3 g's, 24 here, 3 here, 5 here, that can be grouped together into one power. G to the 24 plus 3 is 27. 27 plus 5 is 32. I added all my g's together. There are 32 g's in this problem that are all being multiplied together. I also have a 2 cubed from here. He was not used at all. And I have a 6 from here. That was not used at all. Truth be told, you could probably simplify this a little bit. This 2 to the 3rd power is 8. If you multiply it out, if you'd evaluate, you'd get 8. And then you could take 8 times by 6 and get, 48. So if you said 48 g to the 32nd power, that's acceptable too. These are equivalent answers. I don't even know if one would be better than the other. They're equivalent. They're the same, essentially. All right, letter L. Now, I'm going to delete letter J here because I need the space. I'm going to move letter K over. So if you need letter J, now's your chance to quickly pause the video. All right, it's gone. Delete, delete, K, slide over, and that way I just have some space for letter A. Don't worry, we're almost done with this part of the video. So, letter L. Things I see, parentheses, distribute the exponents. I'm going to leave this first one alone for right now. I lied. I'm make sure I put down that he is 4 to the first power, and he is 4 to the first power. Times by, so this becomes 4 to the 4th power. I'm multiplying my exponents. And 4 to the 12th power. I'm multiplying my exponents. And down below is 4 to the 6th power. See, everything has a base of 4, which means in the end, I'm only going to have something like 4 to some power. That's going to be my final answer. Now, I can combine this up top. That should give me 4 to the 16th power. 4 plus 12 is 16. And I'm just writing everything else down. So now I can worry about this stuff, the fractions. Like, what's going on here? Well, I've got 1 4 on the bottom, 2 4s up top. So if I cancel out one of these, and I cancel out one of these, I'm left with 1 4 still on the top. The other one, if I look at this, I've got 6 4s down below, 16 4s up top. So if I cancel out 6 of these and 6 of these, I still have 10 more up top. Simplified this fraction, I simplified that fraction, and now I'm left with this, and I can see that I'm going to be adding my exponents. This is 2 powers being multiplied together. I've got a total of 11 4s being multiplied together. I was hoping I could just move the square. So I get an answer of 4 to the 11th power. All right, so let's move on to the last problem for this video. It's a multiple choice. This is example 4. It's probably on the last thing on the back of the first page of the notes. It says, we want to simplify the expression below. Answers should be written with only positive exponents. Okay, so we want to simplify this, and it's going to simplify down to one of these 4. Okay. I was just looking to see, is there anything obviously wrong with any of these 4, but I don't really see anything just yet. So I think the only thing we can do is just start plugging away and see what happens. The first thing I see I'm going to do is I'm going to distribute my exponents. So this 4, that P has an exponent, M has an exponent, the 2 has an exponent. So if I simplify this first step, I'm going to get, oh, I guess I'm going to copy down this whole thing over here as well. M cubed P to the 5th, P cubed times by 2 to the 4th, M to the 4th, P to the 16th, 4 times 4 is 16, over M squared. I cannot add anything here. I cannot add anything here. So now I'm looking for what things can I cancel out. And I see I've got P's here that can cancel, and I've got M's here that can cancel. So if I cancel out 3 of these and 3 of these, I'm left with 2 up top. I cancel out 2 of these and 2 of these, I'm left with 2 up top. And so after I simplified and I canceled stuff out, I'm left with this one, M cubed P squared. M cubed P squared times by 2 to the 4th, M squared P to the 16th. Now, it may be helpful for you to understand that there is actually a little multiply in here. This m cubed is times by p squared, times by 2 to the 4th, times by m squared, times by p to the 16th. And so what that allows us to do is that allows us to rearrange a little bit. Now, I'll be honest with you. Now that I've gotten this far, I'm pretty sure that letters A and D are wrong. Because look at that. They still have fractions. And also, look at this. They didn't even bother to simplify their fractions. They've got m over m. They've got a p over p. So yeah, that one's definitely wrong. And over here, look. M over m, p over p. Definitely wrong. So they didn't even simplify their fractions the whole way they should have. They didn't cancel out top and the bottom. So even though if something else in there was right, if it's technically right, or almost right, it's not completely correct because they didn't cancel the m's and the p's like they should have. Okay, so let's keep going. Let's figure out which of these two it is. So if I combine my p's together, I've got 2 p's here and 16 p's there. If I add them together, that should give me p to the 18th power. Doesn't look like him. It looks like him. Keep going. I want to make sure I'm right. Make sure I didn't screw up somewhere else. Make sure I get these other two numbers. My m's, m to the 5th and m squared, m cubed and m squared add together to give me m to the 5th power. And this 2 to the 4th doesn't really have anything to combine with. You might be going, but they have 16 and I have 2 to the 4th. Well, what is 2 caret 4? 2 to the 4th power is 16. So this is 16 m to the 5th, p to the 18th. Letter B is correct. Okay, that's going to be it for this first video. And then I'm going to stop it here. And then we're going to pick up on the next examples on day 2 of the notes in the next video. So, this has been Mr. Henry. Thank you for watching.